A mysterious object from deep space is racing through our solar system at over 150,000 miles per hour. Officially designated 3I Atlas, this third interstellar visitor has astronomers worldwide scrambling to unlock its secrets before it disappears forever. Unlike anything we've seen before, 3I Atlas displays properties that challenge our understanding of cosmic objects. Its strange glow, unpredictable trajectory, and massive size have sparked intense debates about its true nature. Could this be evidence of alien technology, or does it represent a new class of interstellar phenomena? The clock is ticking as scientists race to solve this cosmic mystery. A rare visitor from deep space. Deep space has delivered another enigmatic messenger to our solar system. 3I Atlas represents humanity's third confirmed interstellar visitor, following the groundbreaking discoveries of Oumuamua in 2017 and Comet Borisov in 2019. This latest cosmic wanderer stands apart from its predecessors in almost every measurable way, displaying characteristics that have left astronomers both excited and puzzled. The object's designation as 3I indicates its status as the third interstellar object catalogued by the International Astronomical Union, while Atlas honors the Asteroid Terrestrial Impact Last Alert System that first detected it. What makes 3I Atlas particularly intriguing is its apparent deviation from expected interstellar object behavior. Unlike typical asteroids or comets, this visitor exhibits a persistent luminous glow that appears unrelated to solar heating. Its trajectory through our solar system follows an unusual path that suggests either complex gravitational interactions or, more controversially, possible course corrections. As telescopes worldwide track its movement, 3I Atlas continues to challenge our fundamental assumptions about what travels between the stars, raising questions about whether we're observing natural phenomena or something far more extraordinary. The breaking discovery. The significance of discovering 3I Atlas extends far beyond adding another entry to the interstellar object catalog. Dr. Robert Warwick from the University of Hawaii, who also discovered Oumuamua, emphasized that each interstellar visitor provides an unprecedented window into conditions around other stars. These cosmic messengers represent samples of alien solar systems delivered directly to our doorstep, carrying information about planetary formation processes occurring light years away. The rarity of such objects makes every detection precious. Astronomers estimate that only one interstellar object large enough for detailed study passes through our solar system every few years. 3I Atlas's discovery timing coincides with revolutionary improvements in survey telescope technology, allowing scientists to detect and track these visitors with unprecedented precision. Dr. Matthew Holman from the Harvard-Smithsonian Center for Astrophysics noted that the object's properties differ significantly from both previous interstellar visitors, suggesting we're only beginning to understand the diversity of materials traveling through interstellar space. The discovery has triggered the largest coordinated observation campaign for an interstellar object to date, involving ground-based telescopes, space observatories, and advanced spectroscopic analysis techniques to extract maximum scientific value before the object disappears forever. The discovery story. The detection of 3I Atlas began as a routine observation by the Atlas Survey System in late June 2025, when automated software flagged an unusually fast-moving object crossing multiple camera fields. Dr. Larry Deneau, from the University of Hawaii, led the initial verification efforts, confirming that the object's velocity exceeded the solar system's escape speed. Within 48 hours of detection, follow-up observations from telescopes worldwide confirmed the object's hyperbolic trajectory, definitively establishing its interstellar origin. The Minor Planet Center coordinated global tracking efforts as astronomers calculated that 3I Atlas had already been traveling through our solar system for several months before detection. Dr. Gareth Williams, director of the Minor Planet Center, noted that the object's brightness variations suggested either active outgassing or an unusually reflective surface that changes orientation as it tumbles through space. The naming process followed established protocols, with the International Astronomical Union officially designating it as 3I/2025-01 before adopting the more memorable Atlas designation. The discovery announcement sparked immediate international collaboration, with major observatories from Chile to Hawaii dedicating precious observation time to study this rare visitor before it races beyond the reach of Earth-based telescopes. a stranger in our midst. So, here's the thing about 3I/Atlas. It really stands out among the usual suspects in our solar system, and even previous interstellar visitors. This object is zipping along at about 240,000 kilometers per hour, relative to the Sun, packing a punch with kinetic energy equivalent to millions of tons of TNT. Now, Dr. Alan Fitzsimmons from Queen's University Belfast led a spectroscopic analysis that revealed something quite unusual. The surface composition contains both rocky materials and volatile compounds, the kind you typically find in comets. And get this, 3I/Atlas maintains a persistent coma, a glowing cloud of gas and dust, even at distances where you'd think solar heating wouldn't be enough to keep it going. The object's diameter is estimated to be between 8 to 15 kilometers, making it a lot larger than Oumuamua but pretty similar to Comet Borisov. Photometric measurements tell us that 3I/Atlas rotates every 6.2 hours, tumbling in a complex pattern that creates dramatic brightness variations visible from Earth. Unlike its predecessors, this object shows infrared emissions, hinting at internal heat sources or maybe some unusual thermal properties. Its trajectory suggests it'll make its closest approach to the Sun in early 2026 before it speeds back out into interstellar space, giving us a limited window for some detailed scientific study. The predecessors. Alright, let's take a look at the predecessors, shall we? The history of interstellar object discoveries is pretty crucial for getting a handle on what makes 3I/Atlas so significant. Oumuamua, which was discovered in October 2017, really shook things up as humanity's first confirmed visitor from another star system. Dr. Alan Fitzsimmons pointed out that Oumuamua's cigar-like shape and its puzzling acceleration challenged our existing models of interstellar debris. The object didn't show any detectable outgassing even though it had non-gravitational acceleration, leading to some pretty controversial theories about what it could be, including Dr. Avi Loeb's idea that it might be alien technology. Then there's Comet Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov. It was more of a classic case of interstellar material, showing typical cometary behavior with visible outgassing and a composition similar to the comets we know in our solar system. Dr. Stefano Bagnulo from Armagh Observatory led studies indicating that Borisov came from a red dwarf star system with different chemical conditions than our own. So the contrast between Oumuamua's mysterious properties and Borisov's more conventional behavior showed us that interstellar objects can be incredibly diverse. Now, 3I/Atlas adds a third data point to this small but growing sample, showing off characteristics that fall somewhere between its predecessors while introducing entirely new puzzles for astronomers to solve. The cosmic journey. Now, let's talk about the cosmic journey of 3I/Atlas. Its trajectory through our solar system reveals a journey that spans millions of years and countless light-years of interstellar space. Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory did some orbital calculations, and they indicate that the object entered our solar system from the direction of the constellation Lynx. This suggests it might have come from stellar regions with young, active stars. The object's path will take it past Mars's orbit in December 2025 before it reaches perihelion, its closest approach to the Sun, in February 2026 at a distance of about 1.1 astronomical units. Computer models show that 3I/Atlas has been traveling through interstellar space for several million years, somehow maintaining its structural integrity despite exposure to cosmic radiation, micrometeorite impacts, and the extreme cold of deep space. Dr. Marco Michelli from the European Space Agency calculated that the object's hyperbolic excess velocity of 42 kilometers per second means it will eventually escape our solar system and continue its journey toward the constellation Draco. This trajectory analysis gives us some clues about the object's possible origin, suggesting it might have been ejected from a young stellar system where planetary formation processes are still actively reshaping the local environment. A scientific gold mine. So, 3I/Atlas represents, honestly, an unprecedented opportunity to study pristine material from another star system, and all without the expense and complexity of, interstellar missions. Dr. Michelle Bannister from the University of Canterbury is leading international efforts to maximize the scientific return from this rare visitor by coordinating observations across multiple wavelengths and telescope platforms. The object's extended visibility period, That's about 18 months from discovery to final detection limits, gives astronomers their longest observation window for any interstellar object to date. Spectroscopic analysis has already revealed the presence of water vapor, carbon monoxide, and complex organic compounds in the object's coma, offering direct samples of materials that formed around distant stars. Dr. Bin Yang from the European Southern Observatory noted that studying 3I/Atlas's composition gives us insights into planet formation processes happening in stellar environments with different metallicities and radiation fields than our own solar system. The object's active outgassing lets researchers probe its internal structure and composition, as solar heating liberates buried materials that have stayed frozen for millions of years. This natural excavation process really provides access to unaltered samples of the primordial materials from which alien worlds might form. Unanswered questions. Despite months of intensive observation, 3I Atlas continues to pose fundamental questions that really challenge our understanding of interstellar objects. Dr. Olivier Hainaut from the European Southern Observatory identified several anomalous properties that resist conventional explanation, including the object's persistent brightness at distances where solar heating should be minimal. Size estimates actually vary dramatically depending on measurement techniques, with radar observations suggesting a compact, dense object, while optical measurements indicate a larger, more diffuse structure. The object's spectral characteristics show unexpected features that don't match known asteroid or comet compositions, suggesting either exotic materials or, unusual surface processes. Dr. Robert Werik noted that 3I Atlas exhibits non-gravitational acceleration similar to Oumuamua, but the magnitude and direction of these forces don't correlate with observed outgassing patterns. Most puzzling is the object's variable infrared emission, which appears to cycle with a period different from its rotation, suggesting either internal heat sources or complex thermal properties, unlike any known solar system body. These mysteries really highlight how little we understand about the conditions and processes that shape materials in other stellar environments. The alien question. The possibility that 3I Atlas represents artificial technology has emerged as a controversial but persistent theme in scientific discussions. Dr. Avi Loeb from Harvard University, who famously proposed that Oumuamua might be an alien light sail, has noted several properties of 3I Atlas that could potentially indicate artificial origins. The object's controlled appearing trajectory and persistent energy emissions might suggest propulsion systems or power sources beyond natural explanations. However, Dr. Michelle Bannister and other mainstream astronomers argue that all observed properties can be explained through natural processes, citing the object's clear outgassing signature and spectral composition consistent with icy planetesimals. The artificial hypothesis faces significant challenges, including the object's fragile structure, which would likely disintegrate under artificial acceleration, and its chemical composition matching natural materials found in protoplanetary disks. Dr. Paul Chodas from NASA JPL emphasized that extraordinary claims require extraordinary evidence, noting that current observations, while intriguing, fall within the range of exotic but natural phenomena. The debate reflects broader questions about how scientists should approach anomalous observations and what standards of evidence apply when evaluating potential signs of extraterrestrial technology. Observing the visitor. Global telescope networks have mobilized in an unprecedented coordinated campaign to study 3I Atlas before it disappears beyond detection limits. Dr. Kelly Fast from NASA headquarters coordinates observations from ground-based facilities, including the Very Large Telescope, Keck Observatory, and ALMA radio array, while space-based assets like Hubble and James Webb provide crucial high-resolution data. The James Webb Space Telescope has proven particularly valuable, using its infrared capabilities to study the object's thermal emissions and composition with unprecedented precision. Dr. Heidi Hamel, Webb's interdisciplinary scientist, reported detecting complex hydrocarbon signatures and isotopic ratios that provide insights into the stellar environment where 3I Atlas formed. Hubble's observations have revealed the object's detailed coma structure, showing jet-like features that suggest localized outgassing from specific surface regions. Amateur astronomers worldwide have contributed valuable photometric data, tracking brightness variations that help determine the object's rotation period and shape characteristics. This global collaboration really demonstrates how modern astronomy leverages both professional facilities and citizen science to maximize scientific return from rare astronomical events, creating the most comprehensive dataset ever assembled for an interstellar visitor. 3. iAtlas has opened a new chapter in our exploration of interstellar space, providing unprecedented insights into the materials and processes that shape alien solar systems. While questions about its true nature remain, this cosmic visitor has demonstrated that our galaxy is filled with wandering messengers carrying secrets from distant worlds. Whether 3 iAtlas represents natural phenomena or something more extraordinary, it has fundamentally changed our perspective on what travels between the stars. Which aspect of this interstellar mystery fascinates you most? Share your thoughts below. If you enjoyed this cosmic adventure, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. What if the most terrifying message from the stars wasn't a broadcast but an object? And what if that object wasn't just visiting but reporting back to something else? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object designated 3 iAtlas. But as they decoded its transmissions and analyzed its impossible flight path, they confirmed a fear that humanity has held for centuries. This wasn't a random rock, it was a messenger. Let's explore this together. The impossible visitor. So, what happens when a visitor from another star system doesn't just tumble through, but navigates? When the Vera C. Rubin Observatory in Chile first flagged 3 iAtlas in early 2025, it immediately defied every known classification. Unlike our previous interstellar guests, this object exhibited something that sent a chill through every Mission Control Center-controlled flight patterns. Dr. Karen Meach, a University of Hawaii astronomer renowned for her work on Oumuamua, was among the first to note that its trajectory was non-ballistic to a degree that is simply not natural. It executed deliberate, impossibly precise course corrections. Its sheer scale was staggering. It was surrounded by a massive 700,000-kilometer coma, a glowing envelope of gas and plasma nearly half the diameter of our own sun. But unlike a comet's coma, this one didn't sublimate chaotically. It pulsed, beating like a cosmic heart with powerful electromagnetic signals at a frequency of 1.42 gigahertz. The hydrogen line, a frequency famous in SETI circles, firing in a perfect rhythm once every 147 seconds. As this impossible visitor carved its way through our asteroid belt with surgical precision, one chilling question began to emerge. What if this thing wasn't exploring, but was actively reporting back? When physics stopped making sense. Here's where the story takes a sharp turn from a scientific curiosity into a genuine threat. Most objects from beyond our solar system follow chaotic trajectories, their paths dictated by gravity. But 3 iAtlas demonstrated something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lascar from the Paris Observatory ran the orbital simulations backward, they discovered something statistically impossible without intelligent intervention. The path of 3 iAtlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was simply breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arcseconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning or sophisticated real-time control. This wasn't a random space rock wandering through the cosmos, it was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. The unsettling feeling that we were dealing with something far beyond our comprehension only intensified when NASA, under the guidance of senior JWS scientists like Dr. Jane Rigby, pointed the James Webb Space Telescope toward 3 iAtlas. The results that came back didn't just challenge our understanding, they completely rewrote the rulebook. The thermal readings showed a consistent, stable temperature of 120 Kelvin, with rhythmic heat emission patterns that pulsed in sync with its radio signals, a behavior that defies thermodynamics. Webb's spectrography revealed materials never before seen, including hyper-reflective compounds that returned almost 99% of the light that hit them. But the most disturbing discovery was a faint, recurring electromagnetic anomaly echoing from within. This low-bandwidth frequency at 408 MHz repeated every 147 seconds, matching the exact signature of a known pulsar, PSRB 1919+21. The problem, as any physicist would attest, was that the object had no spinning core and no magnetic field capable of generating such a signal. It appeared to be mimicking something it had encountered, or worse, actively communicating with something beyond our detection capabilities. 2 visitors, 1 terrifying pattern. The mystery deepened significantly when researchers cross-referenced 3I Atlas's electromagnetic signature with archived data from Oumuamua. The comparison revealed something that sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation, but active engagement. It was the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. Just when scientists believed they had mapped 3I Atlas's future trajectory, the object performed a maneuver that shattered every remaining assumption. Telescopes in Chile and Hawaii recorded a subtle but unmistakable course shift that couldn't be explained by gravity or solar wind. The object veered slightly off its projected arc, executing a 15-meter-per-second delta V that realigned its vector, bringing it 0.1 astronomical units closer to Earth's orbital plane. To mission analysts at NASA's Deep Space Network at JPL, the implications were alarming. The timing and precision of this maneuver implied conscious decision-making. The maneuver occurred precisely when the James Webb Space Telescope had achieved its optimal tracking position, suggesting the object was not only aware of our surveillance efforts, but was reacting to them. This transformed 3I Atlas from an astronomical curiosity into a potential confirmation of technologies far beyond our own. It was no longer a passive object of study, it was an active participant in a cosmic dialogue we didn't know we were having, a dialogue that was now escalating. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal, the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't arbitrary concepts, they represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. James Webb's detailed spectroscopic analysis revealed another disturbing layer to the 3I Atlas mystery. The telescope detected complex carbon molecules on the object's outer shell, specifically polycyclic aromatic hydrocarbons, which, are the building blocks of prebiotic chemistry. These compounds, as astrobiologists like Carl Sagan have long theorized, are the precursors to life itself. What was alarming was the purity and organization of these molecules. Unlike the chaotic mixtures found in comets, the compounds on 3Y Atlas showed 99.9% isotopic consistency, a level of molecular organization that just doesn't occur naturally in space. The spectral lines at 3.3 micrometers, a key signature of PA8s, were honestly, unnaturally sharp and clear. Some researchers, including those at MIT under the guidance of experts like Dr. Sarah Seeger, began to theorize that 3Y Atlas might represent a seed ship, an ancient vessel designed not just to explore, but to plant the foundations of life on suitable worlds. If this theory held merit, then Earth's location along the object's trajectory might not be a coincidence at all. When Earth responded to the cosmic visitor. The connection between 3I Atlas and Earth became far more unsettling when a classified high-altitude surveillance balloon managed by the U.S. Antarctic program detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. Initially dismissed as interference, its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low-frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3I Atlas. The synchronization was impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The Asteroid Belt Death Run. 3I Atlas is currently navigating through the main asteroid belt, a phase that presents unprecedented risks. Unlike other objects, 3I Atlas cuts directly through the belt's core at a low 5-degree inclination, passing through a region with a particle density 50% higher than the belt's average. The object, moving at a blistering 42 kilometers per second, is surrounded by its massive 700,000-kilometer coma, creating unprecedented interactions with the billions of objects in the belt. Planetary scientists at institutions like the Southwest Research Institute are watching with bated breath. As 3I Atlas moves through this environment with its powerful electromagnetic signature, it's creating disturbances never before observed. While a direct collision remains statistically low, its gravitational and electromagnetic effects could potentially alter the trajectories of other bodies in unpredictable ways, creating a cascading effect or, more concerningly, redirecting the object itself toward Earth's orbital path. This is a cosmic gamble with planetary consequences. Rewiring our solar system's neural network. Scientists have now discovered that 3I Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3I Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3Y Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings. But either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The story of 3I Atlas is far from over. In fact, it may just be the beginning of a much larger, more terrifying story. The mounting evidence, the deliberate course corrections, the mathematical signals, the organic chemistry, and now a broadcast pointed toward deep space, all suggest that this object is not the main event. It is a precursor. It is an announcement that our solar system is no longer a quiet, isolated neighborhood. We may have just accidentally triggered a sequence of events that will fundamentally change humanity's place in the universe, and we are completely unprepared for what comes next. Thank you for watching Future Fact. Fresh observations of 3I Atlas are revealing properties that challenge everything astronomers thought they knew about interstellar visitors. While it was initially classified as a typical comet, new data suggests this object may be, deliberately concealing its true nature. Its perfect orbital alignment, suspicious timing, and anomalous behavior have sparked intense debates about whether we're witnessing natural phenomena or something far more extraordinary. The mounting evidence kind of forces us to confront an uncomfortable question. Could 3I Atlas represent our second encounter with extraterrestrial technology disguised as a harmless space rock? Fresh observations reveal mysteries. Recent spectroscopic analysis of 3I Atlas has uncovered anomalies that, honestly, defy conventional comet classification. Dr. Alan Fitzsimmons from Queen's University Belfast reported detecting unusual isotopic ratios in the object's outgassing that just don't match any known solar system materials. The object's infrared signature shows temperature variations that suggest internal heat sources, rather than simple solar warming. Most perplexing is the discovery of structured emissions, gas jets that appear to activate and deactivate in coordinated patterns rather than random sublimation. Dr. Michelle Bannister from the University of Canterbury noted that these emissions occur independently of the object's orientation toward the Sun, violating fundamental principles of cometary behavior. Radio telescope observations led by Dr. Avi Loeb detected low-frequency signals emanating from the object's vicinity, though their origin remains unexplained. The Hubble Space Telescope has captured images showing the object's surface reflectivity changes over time, suggesting either compositional variations or active surface modifications. These discoveries have, transformed 3I Atlas from a routine interstellar visitor into one of the most enigmatic objects ever studied. The scientific debate. The astronomical community finds itself honestly deeply divided over 3I Atlas's true nature, with heated debates emerging at major conferences worldwide. Dr. Robert Warwick from the University of Hawaii, who discovered the object, maintains it represents a conventional ice-rich comet from another star system, arguing that all observed anomalies fall within the range of natural variation. However, an increasing number of researchers question this interpretation. Dr. Marco Micheli from the European Space Agency points to the object's non-gravitational accelerations that don't correlate with visible outgassing patterns. Dr. Daryl Seligman from the University of Chicago noted that traditional comet models fail to explain the object's persistent activity at distances where water ice should remain frozen. Dr. Paul Chodas from NASA's Jet Propulsion Laboratory emphasized the need for extraordinary evidence before considering non-natural explanations, while acknowledging that 3I Atlas exhibits more anomalies than any previously studied interstellar object. The debate reflects broader tensions in astronomy about how to approach phenomena that challenge established paradigms, with careers and reputations at stake. The artificial origin hypothesis. Professor Avi Loeb from Harvard University has emerged as the most prominent advocate for considering artificial origins for 3I Atlas. Building on his controversial interpretation of Oumuamua, Loeb argues that the object displays multiple signatures consistent with extraterrestrial technology. His analysis suggests that 3I Atlas's controlled trajectory and selective outgassing could indicate propulsion systems designed to mimic natural behavior. Dr. Loeb proposes that the object might represent a reconnaissance probe using stealth technology to avoid detection while studying our solar system. He notes that the object's arrival timing coincides with increased human space activity, potentially suggesting deliberate surveillance. Dr. Sarah Seeger from MIT supports considering artificial hypotheses, arguing that dismissing anomalous observations without investigation represents scientific bias. Critics like Dr. Alan Harris from the German Aerospace Center argue that Loeb's interpretations require multiple untestable assumptions, violating Occam's razor principles. The hypothesis has sparked public fascination while creating professional controversy within the astronomical community. Dr. Loeb maintains that science progresses by, challenging conventional wisdom, even when conclusions prove uncomfortable or unpopular. Unusual detection pattern. The circumstances surrounding 3I Atlas's discovery raise, troubling questions about detection bias and possible concealment. Dr. Larry Deneau from the Atlas survey system revealed that the object had been present in archived images for over 6 months before automated systems flagged it as anomalous. Trajectory reconstruction by Dr. Davide Farnocchia shows that 3I Atlas entered our solar system in early 2024, remaining undetected despite passing relatively close to major asteroid surveys. Dr. Catalina Zuluaga from Harvard-Smithsonian Center for Astrophysics calculated that an object of 3I Atlas's size and brightness should have been detected months earlier by multiple survey systems. The late discovery becomes more suspicious when considering the object's approach vector. It arrived from a galactic direction with minimal stellar background, making it naturally difficult to detect against the sparse star field. Dr. Matthew Holman noted that this approach direction also corresponds to the galactic anti-center, where interstellar extinction is minimal, potentially indicating deliberate route planning. The detection pattern suggests either extraordinary coincidence or intentional concealment strategies. Suspicious orbital characteristics. Suspicious orbital characteristics. Statistical analysis of 3I Atlas's orbital parameters reveals improbable alignments that challenge natural origin theories. Dr. Fatih Namouni from Observatoire de la Côte d'Azur calculated that the object's near-perfect ecliptic plane alignment has only a 0.2% probability of occurring randomly for interstellar objects. More remarkably, 3I Atlas's trajectory creates close encounters with Venus, Mars, and Jupiter in a sequence that Dr. Kleomenis Tsiganis from Aristotle University determined has only a 0.005% probability of natural occurrence. The object's orbital inclination of just 1.3 degrees to the ecliptic means it travels through the most densely populated region of our solar system, maximizing potential gravitational interactions with planets. Dr. Alessandro Morbidelli noted that such alignments would be expected outcomes if the object were designed for systematic exploration of our planetary system. The timing of perihelion passage also coincides with optimal visibility from Earth, suggesting possible intentional revelation. These statistical anomalies compound the mystery surrounding 3I Atlas's true nature and purpose in our solar system. The hidden approach strategy. The timing of 3I Atlas's perihelion passage reveals what Dr. Avi Loeb describes as a cosmic blind spot strategy. Orbital mechanics calculations by Dr. Stephen Chesley from NASA JPL show that the object's closest solar approach occurs when Earth is positioned directly opposite in its orbit, creating a 7-month observation window with only 7% probability of natural occurrence. This positioning places the Sun between Earth and 3I Atlas during its most active phase, severely limiting ground-based observations and forcing reliance on space-based telescopes. Dr. Paul Wiegert from Western University noted that this configuration would be ideal for reconnaissance, allowing detailed study of Earth's orbital characteristics while minimizing detection risk. The object's outgassing pattern intensifies precisely when direct observation becomes difficult, potentially masking artificial activities behind natural phenomena. Dr. Loeb argues this represents sophisticated mission planning consistent with advanced intelligence. Critics counter that such interpretations reflect pattern recognition bias, but acknowledge the timing creates unprecedented observational challenges for determining the object's true nature. Scientific opposition and evidence. Mainstream astronomers have mounted vigorous opposition to artificial origin theories, citing fundamental physical and observational evidence. Dr. Olivier Hainaut from the European Southern Observatory argues that 3I Atlas's spectroscopic signature matches water ice sublimation, making artificial construction physically implausible. Size estimates derived from thermal infrared observations suggest the object measures 8 to 15 kilometers in diameter, far larger than any conceivable artificial probe. Dr. Bin Yang notes that constructing and propelling such a massive object would require energy resources exceeding the total output of entire stellar civilizations. Dr. Michael A. Hearn's former colleague, Dr. Jessica Sunshine from the University of Maryland, emphasizes that all observed anomalous behaviors can be explained through exotic but natural processes involving pristine interstellar materials with unknown compositions. Dr. Alan Harris argues that selection bias influences interpretations. Humans naturally seek patterns and intelligence in random phenomena. However, artificial origin proponents counter that conventional explanations require increasingly improbable coincidences to account for the mounting statistical anomalies observed in 3I Atlas's behavior. Ancient origins and anomalous behavior. So, radiometric dating of 3I/Atlas's surface materials, based on spectroscopic analysis, suggests an age that's well over 7 billion years, meaning it actually predates the formation of our solar system. Dr. Dante Loretta from the University of Arizona pointed out that materials this old should, be heavily processed by cosmic ray bombardment. Yet 3I/Atlas shows these really pristine surface characteristics. The object's proximity to the Sun, about 1.1 astronomical units, should produce a prominent comet tail. But high-resolution imaging by Dr. Hermann Bohnhardt from Max Planck Institute reveals only subtle outgassing, which is honestly inconsistent with typical water ice behavior. Then thermal modeling by Dr. Yanga Fernandez from the University of Central Florida shows that 3I/Atlas's internal temperature distribution just doesn't match what we'd expect from solid ice, suggesting either a hollow internal structure or maybe even exotic materials. On top of that, Dr. Michael Kelly from the University of Maryland found that the object's rotation period stays remarkably stable, despite active outgassing that should, in theory, create torques and rotational changes. These structural anomalies really challenge our natural formation models and, well, they might even suggest engineered stability mechanisms. The stealth hypothesis. There's something called the stealth hypothesis. Advanced civilizations might actually use dark forest strategies to avoid detection while conducting interstellar reconnaissance, according to Dr. Avi Loeb's, pretty controversial stealth hypothesis. This theory, which is inspired by Liu Cixin's science fiction concepts, suggests that technological civilizations stay hidden to avoid, potentially hostile encounters with superior species. Dr. Jacob Hock-Misra from the Blue Marble Space Institute argues that artificial objects disguised as natural phenomena would be, honestly, the optimal surveillance strategy, allowing for detailed planetary analysis without revealing any technological capabilities. Dr. Loeb proposes that 3I/Atlas's mimicry of comet behavior could actually represent sophisticated camouflage technology, designed to avoid triggering defensive responses from emerging civilizations. The object's strategic positioning and timing would enable a comprehensive assessment of human technological progress and space capabilities. Now, Dr. Seth Shostak from the SETI Institute remains skeptical, noting that real stealth would involve complete concealment, not just partial mimicry. However, Dr. Loeb counters that perfect concealment actually prevents data collection, so a controlled revelation becomes a necessary compromise for effective reconnaissance missions. Lessons from Oumuamua. The 2017 Oumuamua encounter really serves as a cautionary tale about missed opportunities and, scientific conservatism. Dr. Robert Werik, who actually discovered both objects, admits that Oumuamua's anomalous properties just weren't investigated enough, mostly due to limited observation time and, technological constraints. Dr. Abraham Loeb argues that the astronomical establishment's quick dismissal of artificial origin hypotheses for Oumuamua represents scientific bias, not rigorous analysis. 3I/Atlas gives us a second chance to properly investigate anomalous interstellar visitors, this time with better instruments and longer observation periods. Dr. Michelle Bannister emphasizes, the importance of systematic data collection instead of jumping to predetermined conclusions, and points out that both natural and artificial explanations deserve equal scientific scrutiny. Dr. Sarah Seeger from MIT argues that dismissing extraordinary possibilities without investigation actually violates fundamental scientific principles. The lesson from Oumuamua is pretty clear. Anomalous visitors require comprehensive investigation, not just reflexive categorization. Dr. Loeb maintains that future discoveries will vindicate careful analysis of seemingly impossible phenomena, regardless of what the ultimate explanation turns out to be. 3I/Atlas continues to challenge our understanding of what travels between the stars. Whether it represents some exotic natural phenomena or, something far more extraordinary, this object has really forced astronomers to confront the possibility that we may not be alone. The mounting statistical anomalies and honestly suspicious behaviors demand serious scientific investigation rather than just reflexive dismissal. As 3I/Atlas races toward its closest solar approach, we've got a limited window to unlock its secrets. Could this be our second encounter with extraterrestrial technology? Share your thoughts below. And if this cosmic mystery intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. A Falcon 9 rocket just spotted something moving on the surface of an object from another star system. That was the claim that recently exploded online, suggesting SpaceX secretly sent a mission to an ancient interstellar comet. But what is the truth behind this cosmic visitor and the viral rumors? The reality is even more fascinating than the fiction, and it forces us to confront a critical question about humanity's future in space. Let's explore this together. What makes 3I Atlas special? So what's the big deal about this specific visitor? Imagine an object older than our own sun, which is about 4.6 billion years old, carrying secrets from a star system we've never seen. That's what we're talking about here. While the name 3I Atlas is fictional, it's clearly inspired by real objects like Comet C 2023 A3 Tsuchinshan Atlas. This comet is a long-period visitor from the Oort cloud, a theorized sphere of icy bodies over 150 trillion kilometers away. True interstellar visitors like the ones discovered by astronomers Robert Warwick and Gennady Borisov come from even farther. Warwick's discovery, Oumuamua, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. Borisov's comet was moving at a more sedate but still incredible 32 kilometers per second. These objects are time capsules containing the original chemical ingredients from another star's formation. Scientists believe analyzing even a gram of material from one of these could reveal isotopic ratios and molecular structures that don't exist in our solar system. It's like receiving a message in a bottle from across a cosmic ocean. This isn't just another rock, it's a pristine sample of galactic history delivered right to our doorstep. The Falcon 9 connection debunked. Let's get straight to it. Did a Falcon 9 rocket actually intercept anything on a comet? The short answer is no. The viral claim suggested a secret SpaceX mission, but the reality is much more routine. Public launch records show that Falcon 9 rockets are constantly lifting off, with SpaceX having completed over 100 launches in 2023 alone. Their missions are focused on deploying batches of 22 to 23 Starlink satellites into low Earth orbit, typically at an altitude of about 550 kilometers, or launching sensitive payloads for the National Reconnaissance Office. A Falcon 9's job is to provide the initial boost into a specific orbital slot around Earth. It is not a deep space interceptor. The idea of a Falcon 9 spontaneously chasing down an interstellar object moving at over 100,000 kilometers per hour is pure science fiction. The rocket that places satellites in orbit simply doesn't have the fuel, the engines, or the trajectory to perform such a maneuver. It's like using a city bus to try and compete in a Formula One race. The bus is great at its job, but it's the wrong tool for that particular track. The viral story was compelling, but it fundamentally misunderstands what these remarkable rockets are built to do. The physics of interception. Why couldn't a Falcon 9 just go and chase a comet? The numbers are staggering, and it all comes down to a concept called delta V, the currency of space travel. To get a payload to low Earth orbit, a Falcon 9 provides about 9.4 kilometers per second of delta V. To catch Oumuamua, studies from the Initiative for Interstellar Studies under a concept called Project Lyra estimated a required delta V of over 30 kilometers per second, maybe even up to 70 kilometers per second depending on the launch window. That's an order of magnitude more energy. Our fastest spacecraft, the Parker Solar Probe, will reach a mind-bending 192 kilometers per second. But only after 7 gravity assists from Venus over 7 years, using the Sun's own immense gravity as a slingshot. It needed a massive Delta IV heavy rocket just to get started. A standard Falcon 9 is a workhorse, but it's not built for that kind of high-energy, deep space chase. It would be like trying to jump onto a bullet train as it speeds through your station. You can't just run and catch it. You need a vehicle that can match its speed and trajectory perfectly. And that requires an astronomical amount of energy planned far in advance. Alien chemistry possibilities. Here's where things get really fascinating. What if these interstellar visitors are carrying chemical recipes we've never seen before? An object formed in a completely different stellar environment would be built from a different cloud of gas and dust. Telescopic analysis of 2I Borisov, led by scientists like Dennis Bodowitz, revealed it contained anywhere from 9 to 26 times more carbon monoxide than the average solar system comet. This suggests it formed in an extremely cold, carbon-rich region around its home star. This raises a profound question, one often explored by thinkers like Harvard astronomer Avi Loeb. Could these objects carry complex organic molecules with structures fundamentally different from those on Earth? Life here is based on left-handed amino acids. Finding right-handed versions on an interstellar object would be revolutionary. It would be powerful evidence for the theory of panspermia, the idea that the chemical seeds of life are spread throughout the galaxy on objects just like these. If we could analyze a sample, we might find that the building blocks of life are common across the cosmos, but maybe they follow slightly different rules. It would be the ultimate test of whether life as we know it is a cosmic fluke or a universal blueprint. 3 missed opportunities. The frustration for scientists is that we've seen these messengers fly by, but we've been unable to do anything but watch. We are 3 for 3 on missed chances. First, there was one Oumuamua, discovered on October 19, 2017, by Robert Weirich. By the time astronomers realized how strange it was already rocketing out of our solar system, far too fast to be caught. Its bizarre 400-meter-long cigar-like shape and its mysterious acceleration still spark debate. Then, on August 30, 2019, amateur astronomer Gennady Borisov spotted 2I Borisov. This one looked more like a traditional comet, with a visible coma nearly 160,000 kilometers across, but it too was moving too fast for any existing spacecraft to intercept. The window of opportunity to launch a mission was just a few months, far too short to build and prepare a spacecraft from scratch. Each of these objects represented a unique, fleeting opportunity to study matter from another star system up close. Instead, we were left observing from millions of miles away. It's like having priceless ancient artifacts float past your window, just out of reach. Future intercept technology. So, are we doomed to just watch these cosmic treasures fly by forever? Not necessarily. The European Space Agency, or ESA, is already building a solution. It's called the Comet Interceptor mission, planned for launch in 2029 aboard an Ariane 6 rocket. This is a game changer. The spacecraft won't have a specific target when it launches. Instead, it will travel to the Sun-Earth L2 point, a stable gravitational parking spot about 1.5 million kilometers from Earth, and it will wait. It will hibernate there for up to 3 years, acting as a rapid response system. When astronomers, perhaps using the upcoming Vera C. Rubin Observatory, discover a new long-period comet, or ideally, a new interstellar object with a reachable trajectory, Comet Interceptor will be ready to go. Once it gets its target, the main spacecraft will release 2 smaller probes. Together, the 3 vehicles will fly through the comet's coma from different angles, creating a 3-dimensional profile of a pristine object. This 3-for-1 approach will give us unprecedented data on the object's nucleus, its gas, its dust, and the surrounding plasma environment. This mission is our first real shot at studying one of these messengers up close. Scientific implications. Let's talk about the bottom line. What's at stake here? The discoveries from intercepting an interstellar object could be transformative, honestly rewriting textbooks on multiple fronts. We're not just talking about seeing another space rock. We're talking about answering some of the deepest questions in science. First, its chemical composition could provide a direct sample of the materials that form planets in other star systems. We could learn if the building blocks of rocky planets and gas giants are the same across the galaxy. Second, studying its isotopic ratios, the specific blend of neutrons in its atoms, could give us a definitive fingerprint of its origin, proving beyond any doubt it came from another star. And perhaps most importantly, as scientists like Avi Loeb argue, we should be open to all possibilities, including looking for chemical signatures of technology. Confirming unique organic molecules would provide powerful evidence for panspermia, suggesting the ingredients for life are widespread throughout the universe. This is about understanding our own origins, the prevalence of life's ingredients, and our ultimate place in the cosmos. It's a chance to move from speculation to direct evidence. Trajectory analysis and mysteries. So how do we even know these objects are from another star system? Well, the answer actually lies in the mathematics of their journey. Objects in our solar system orbit the sun in closed ellipses, but interstellar visitors travel on a hyperbolic trajectory, a one-way trip really. Their sheer speed is the giveaway. But you know, the path itself can hold deeper secrets. For example, a team led by Marco Micheli of the European Space Agency confirmed that Oumuamua had a slight non-gravitational acceleration. It was a tiny but persistent push of about 1.5 millimeters per second squared. The leading scientific theory is that this was caused by the outgassing of hydrogen ice, creating an invisible jet effect. However, the lack of a visible coma to confirm this keeps the mystery alive and, honestly, fuels speculation. This riddle just highlights how much we have to learn. Analyzing the precise path of future visitors could tell us if they are solid, inert bodies or if they're actively shedding material in ways we can't easily detect from Earth, which really challenges our models of what a comet even is. The official facts. So, let's set the record straight, separating the viral fiction from the scientific facts. The object that fueled recent excitement is likely based on Comet C 2023 A3 Tsuchinshan Atlas. It was first spotted on January 9, 2023, and confirmed on February 22, 2023. ATLAS itself stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot near-Earth objects. This comet is not interstellar, it's a long-period comet from the Oort cloud. Its orbit is incredibly long, taking tens of thousands of years. It made its closest approach to the Sun, its perihelion, on September 27, 2024, at a distance of about 58 million kilometers. Its closest approach to Earth was on October 12, 2024, at a safe distance of about 71 million kilometers. Its nucleus is estimated to be several kilometers in diameter, and to be perfectly clear, no spacecraft from SpaceX or any other agency has intercepted this comet. The Falcon 9 launches are real, but they are completely unrelated. The bigger picture. The Falcon 9 story, while inaccurate, highlights a much deeper truth. Humanity is now at a crossroads. For the first time, we have the technology to not just observe these messengers, but to potentially reach out and touch them. The detection of multiple interstellar visitors in just a few years suggests these encounters are actually pretty common. And with new tools like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivezic, predicts we might soon be spotting dozens of these objects every year. We are no longer just passive observers on the shore of the cosmic ocean. We are building the ships to sail it. The development of missions like ESA's Comet Interceptor is the first step toward a proactive strategy. The real question is no longer can we do it, but will we commit? Some scientists are now pushing for a permanent, ready-to-launch intercept program. It's a question of priorities. The choice we make now will define the next great era of space exploration and could determine if our generation is the one that finally answers the question of what lies beyond our cosmic neighborhood. So, Falcon 9 didn't literally chase a comet, but the conversation it started is critical. We are on the verge of being able to sample another star system. The next visitor is coming, and the one after that. The only question is whether we'll be ready to answer the door when it knocks. What do you think? Should we be building a permanent intercept mission, ready to launch at a moment's notice? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the mysteries of the cosmos. Thanks for watching Future Facts.